Agmos here, Supply Chain Dynamics, Chapter 10, Travail, Transparency and Trust. Sysdea Gameplay 7, Chaotic Behavior. This supply chain most of the time seems to be operating in a fairly orderly and predictable manner. That's of course the case in a situation where both parties start trusting each other rather a bit and there's no change really in demand. And actually everything in this model is really stable. There's a first period in which everything has to finalize, as we see here in the trust and transparency on both sides. The same is a little bit true in the production rate. It fluctuates a little bit in the beginning. It's true in the order rate communicated to A, but really not a lot. And for a long time, the system continues to operate in this orderly manner as we continue to add turbulence to it. One very obvious way of adding turbulence to it is by making the demand change a little bit. We make it change a very little bit, like we have 5% demand increase for the demand that the customer B is facing. As a result of this, the customer also has to order more of the product A with supplier A. There's really no change. If we make that a 10% increase, then there's a bit of a change. We see that the supplier is a bit disappointed in B, but not really much. Let's continue doing this with 5% increase, 5% increase, a bit more. And let's see then what happens. Well, now at 50%, there is a fairly predictable dip, but you also see is the customer has no problems with this, but there is indeed some unreliability with the supplier in the perception of with the customer in the perception of the supplier, but it gets fixed. You see that the amount of production that starts go up, but it does bounce back again. Let's continue this a little bit, and let's see the level that we had before of 20%. Now, also here the increase is almost proportional. We have a little bit more distrust or drop in trust with the supplier. And we now also see that the customer is picking up this, especially the results of this behavior with from the supplier. But also, of course, there's some distrust coming here from the fact that the supplier isn't able to meet that much demand all of a sudden. If we continue to move further up, to say 25%, we then get into a totally different region. In this region, also the customer has wild fluctuation in trust, and even the supplier, well, he never really basically recovers. If we move to the 30%, then the customer still recovers. The supplier also, interestingly, in this at this level, and please remember that last time with a smaller demand increase, so less unreliable behavior from the customer, he was more long-term disappointed, and we'll continue to do that in a little minute, look at that a bit more. And then you see with 35%, both of them end up never trusting each other. So there's this one-time change, they don't survive from that. If I do that 40%, same thing basically with some noise around here, 50%. The same story basically. Can go on and on. This you could call again orderly behavior. It's the same thing every time, so pretty robust regardless of the size of the increase of the demand. After more than 30%, the system responds every time the same way. But between 20 and 30%, there was an interesting phase, and let's return there for a while then. So at 20%, this was the increase that we had. Let's now add some smaller increments. Let's just move 1% more. Totally different. So this is 20%. And this here. So 21%, and this is 20%. 20%. 21%. Totally different behavior. 22%. What does that do? Looks a bit like 21. 23%. Also, well, okay, how about 24%? Getting different. Now the supplier never survives and the customer keeps fluctuating. So just 1% more demand, mind you. 25%. Looks a bit like 24. Let's be bold, 27%. Now both of them recover again. Okay, how about 29%, 28%? Yeah, both recover, looks a bit like that, so 29% is probably like that again. Yeah. So somewhere between 20 and 26, 27%, behavior can be all over the place. And that's, so for minuscule changes in the end customer demand, you get very wild differences in behavior for the rest of the system. Just look at the two differences in backlog here. Let's just to make really a point of what I mean, between 20 and 21%. This is 20 and the other one is 20%. Here you see, for instance, the degree in finished product, totally different. Degree in production starts, totally different. The behavior for indeed the actual order rate, quite different. Just 1% change. So from 20% onwards, this model moves into what they call a chaotic behavior. The idea that very small changes in the inputs can lead to a fully deterministic system. There's no noise in there. The variables, the formulas react every time. Same thing if you give them the same input, they have the same output. Only very small variations in that input can lead to very large differences in the output. And that's what we call chaotic behavior. Seemingly, apparently stochastic behavior in a deterministic system. And it's interesting to see that it can happen in the model, because it certainly can also happen in the real world.